In this lesson, we're going to cover surface area and volume of a sphere. We have a sphere is going to be a set of all points that are going to be equidistant from a given point called your center. A radius is going to be a segment that is going to have one endpoint at the center and another endpoint on the sphere. A diameter is going to be a segment where it's going to pass through your center and it's going to have two endpoints on the sphere. When a plane and a sphere intersect in more than one point, the intersection is a circle. If the center of the circle is also the center of the sphere, then we call this a great circle. The circumference of a great circle is the circumference of the sphere. A great circle is going to divide a sphere into two hemispheres. All right, so we have our formulas down here that we will need to know. So for our surface area, we have our sphere is 4 pi r squared, and our hemisphere is 3 pi r squared. When it comes to volume, our sphere is 4/3 pi r cubed, and our hemisphere is 2/3 pi r cubed. So let's look at some practice problems and see what we can figure out from them. So for number 1 here, we have find the surface area of a sphere whose diameter is going to be 18 feet. So I'm going to start off with finding my radius, which is just going to be me dividing that diameter by 2 to get 9. From there, I can just plug into my formula, which we have is 4 pi my radius squared. Okay, so 4 times 81, so that 9 squared, is just going to give me 324 pi. And then we'll include our units of feet squared. So that one was pretty simple. Now let's look at number 2. In number 2, we are finding the surface area of a sphere where one of its great circles is going to have an area of 36 pi inches squared. So because our great circle has an area of 36 pi inches squared, that right there should have the same radius as our sphere. And so all we really need to do here is take the 4 pi radius squared, which is known as that 36 pi that they gave us, and multiply together. So here, 4 times 36 is going to give me 144 pi, and we'll have our inches squared. Now, to clarify, if they were giving us circumference, we would need to find the radius. But here in area, they use the radius squared, and our formula is 4 pi r squared. So we're just replacing that part of it with what we have. All right, now let's move into number 3. So in number 3 here, some people got confused in class, but the circumference of a rubber ball is 13 centimeters. Not a typo, it is 13 centimeters. We're going to find its surface area. So in order to do that, we need to start off with finding our radius. Okay, so circumference is going to be 2 pi r, which is going to be equal to that 13. So I'm going to divide both sides by 2 pi. And when I do that, I'm going to be left with my radius is equal to 13 divided by 2 pi. And you can simplify if you would like to 6.5 over pi, or I'm just going to leave it as 13 over 2 pi. So now that I have my radius and we're finding our surface area, we're going to just plug into our formula, 4 pi, and then our radius squared. All right, so I'm going to go ahead and square that. We have our 4 pi. In the numerator, we're going to get 169. And in the denominator, make sure you also square the pi. It is going to be 4 pi squared. Okay, and so I'm going to rewrite this to show what's going to happen when I multiply. We're going to have that 4 pi in the numerator with that 169 over 4 pi squared. Okay, so here I'm seeing the pi's and the 4's in common, so I'm going to cancel out. But here, make sure that when I cancel out my pi, I'm canceling out the squared, not the pi, because I'm getting rid of one of them, which is going to get rid of that squared part of it, but I should still have a pi left over. So with that being said, my final answer for my surface area would be 169 over pi, and we would have centimeters squared. All right, now let's look at number 4. So for number 4 here we have find the volume of a sphere whose diameter is 30 centimeters. So once again, I'm going to start off by finding my radius. So I'm going to take that 30 and divide it by 2 to get 15. Okay, then plugging in for my volume, we have 4/3 pi 15 cubed. Okay, so if I didn't have a calculator and I was working this out, I would probably go ahead and rewrite this as 4/3 pi, and then we have 15 times 15 squared. And the reason why is because here I'm going to see that 3 and that 15 can simplify, and I would just get a 5 that divide by 3 would disappear. And so in the end, when I simplify one more time, I'm going to get 20 pi, that 4 times 5, times, and my 15 squared gives me 225. So when I multiply those two together, I'm going to end up with 4,500 pi, and we'll have our centimeters cubed. Okay, now let's look at number 5. The volume of a sphere is 32/3 pi meters cubed. We're going to find the surface area of the sphere. So in order to find the surface area, I need to figure out what is the radius. So I'm going to take my volume. We have that 32/3 pi is going to be equal to, and I'm going to set it equal to my volume formula, which is that 4/3 pi radius cubed. So to start off, I'm going to go ahead and multiply both sides by 3, which will give me 32 pi equal to 4 pi radius cubed. Then I'm going to divide both sides by 4 pi, and I'm going to end up with 8 is equal to that r cubed. So I'm going to take the cube root of both sides. And it's very similar to taking the square root. I'm going to look for my factors. I've got 4 and 2, and then 2 and 2. The part that is going to be different when we're taking the cube root is when we take the square root, we find our pairs, we pull them out. Here with the cube root, we are going to look for a set of 3 of a kind, which I do have. I have my 3 2's. Then I can pull that out. And so that's going to leave me with my radius is equal to 2. So now that I know my radius, I'm going to plug in for my surface area, which is that 4 pi radius squared. And so 2 squared is going to give me 4. 4 times 4 gives me 16 pi meters squared. All right, now let's move on to the last problem for the front side. We have the volume of a sphere is going to be 2,304 pi inches cubed. We're going to find its surface area. So we're going to take very similar steps as what we did before. We're just going to have a different number this time. So I've got 2,304 pi equal to that 4/3 pi radius cubed. Okay, so like I did in the previous one, I'm going to start off by multiplying both sides by 3 so I can get rid of that fraction. And that 2,304 times 3 is going to give me 6,912. Pi is equal to 4 pi radius cubed. Now I'm going to divide both sides by that 4 pi, and I'm going to end up with 1,728 is equal to my r cubed. Okay, so like before, we're going to take the cube root to figure out what my radius is. So here, I'm going to go ahead and try and find some factors. I'm going to start with 4. I think this might divide by 4. And so I'm going to end up with 432. Then I'm going to divide by another 4 to get 108. And then I'm going to go ahead and keep on that same roll so that I have a set of 3 that I can pull out of those 4s. And so when I divide, I'm going to get 27. Well, then focusing on that 27, I know that 3 times 9, and then that 9 can be broken down into 3 times 3. So here I have a group of 4 that I'm going to pull out. Sorry, I was trying to remember the word. And a group of 3 I'm going to pull out. So when I do that, I'm going to get 12, and therefore my radius is 12. Okay, so with that being said, now that we know my radius, we can plug in that 4 pi 12 squared, which 12 squared is going to give me 144, times 4 should give me 576 pi inches squared. All right, now moving on to our last problem on the back side. We have 2 parts to it. We have C is the center of the sphere, and plane B is going to intersect the sphere in circle R. Suppose that CR is going to be 5 and SR is 12. We want to find the length of the radius of the sphere. So looking at what we have here, we have that C is our center of the sphere, and there is a plane located below it slicing through, so that my R is the center of that one, and S is going to be a point in that plane that intersects the sphere. Well, when this is going to happen here, you are going to be able to connect all of these points into a triangle, and it's going to end up being a right triangle. Okay, so with that being said, I'm just going to come over here. I'm going to redraw. And let's go ahead and label. So we had our C, R, and our S. They told me that SR was 12 and that CR was 5. So we're using that Pythagorean theorem, because it is a right triangle, to figure out the length of my radius, which will be that CS. So we'll have 5 squared plus 12 squared is equal to C squared. So 25 plus 144 is equal to my c squared. I'm taking the square root of 169 to get my c, which is going to give me 13. So my radius is going to be equal to 13 units. All right, now let's look at part B, which is pretty much the same thing. They're just giving us different lengths. We have if the radius of the sphere is 41, so let me redraw. And the radius of the sphere was that CS, so that's going to be 41. And the radius of circle R is 40, which is going to be this length here from R to S, since R was the center of that circle and S was the point on the sphere. We want to find CR. So we're going to take our 41 squared is going to be equal to 40 squared plus B squared. When we square everything, we're going to get 1,681 is equal to 1,600 plus B squared. When you subtract, you're going to be left with 81 is equal to that B squared, and therefore B is equal to 9. And so my CR is equal to 9 units. And there you have it for our notes over surface area and volume of spheres.